and welcome to the Space Policy Show. I'm Colleen Stover with the Aerospace Corporation. I had the opportunity to attend the 13th annual conference of the IAASS, or the International Association for the Advancement of Space Safety. It was held in Prague this year, and IAASS brings together safety experts from all around the world to discuss both the technical and governance challenges around space safety, and to foster international cooperation. So to that end, the Space Policy Show went on the road, and we were able to talk to people that attended the conference in Prague. You can see here from the brochure that the theme of this year's conference is building a safe, secure, and sustainable space. And so I asked some attendees what those words meant to them. What is safe? What is secure? What is sustainable in terms of space for those individuals? Try to get some different perspectives on that. But I was also able to catch up with the U.S. Air Force Chief of Safety, and we discussed how the increase in launch has an associated increase in risk at U.S. sites for launch. I also caught up with a law professor from the Institute of Air and Space Law at McGill University in Montreal, and she talked about leveraging Article 9 of the Outer Space Treaty about due regard to better develop norms of operations in space. I talked to the IAASS Executive Director about the Emergency Assistance Clause in Section 6 of the Artemis Accords, some of the technical challenges that exist there, specifically on lunar rescue. And finally, I talked to the Director of Flight Safety from the Australian Space Agency on streamlining commercial launch and re-entry regulation in Australia. So thank you so much for joining, and I hope you enjoy the show.
So in the context of space, sustainable means being able to maintain an acceptable set of operating conditions.
Hello there. Sustainable to me means the space that it's not easily destroyed, is reliable and stays consistent in time.
To me, sustainable means long-lasting or into the future.
So I'm here today at the IAASS conference in Prague, and I'm here with Major General Gen Choquette, and he is the Air Force Chief of Safety. So thank you for taking the time to come talk to me.
Thanks for having me. Yeah.
I wanted to ask you, you did make a few remarks earlier today at the conference, and you talked about how there's an increase in launch and what that might mean for an increase in risk. Can you kind of talk about that for a few minutes?
Sure, absolutely. If you look at our two launch deltas on the east and west coast, both ranges, there's been a incremental, not just incremental now, but a significant increase in the pace of launch. Where we were looking at annual numbers of single and double digits years ago, we're now going to be getting up into the triple digits of launches, to the point where we're in the States launching about every 2.5 days. That increase is creating the risk that exists at those launch sites to increase just by simple volume.
Wow, yes. And we have had, we've talked about on the show before, both the Eastern Range and the Western Range in the US, and talking about the safety elements there. So, you also talked in your remarks about launch sighting. So this was a first for me. So I wanted you to kind of talk a little bit about what that means, how launch sighting is affected by tempo. Kind of explain that to our audience.
Sure. These launch sites are places that we've been using since the 1960s. So old infrastructure strategically placed as a perfect place for launch, but because that infrastructure is old and was designed again for single-digit launches, we're having to upgrade a lot of things. And we have a lot of users in that space. It's not just for national defense, and it's not just for national needs or U.S. government needs. There are commercial operators and industry that are involved there in launching. So everybody has a vested interest in making sure that that area is safe and that we're protecting both the public and the shared assets in that area.
Yeah, and so what does what does that look like in terms of creating new launch sites?
I think The new launch sites aren't so much in that area. We're upgrading what we have. There are a number of them already there, and some that have gone to disuse over the years, so I think that we'll be refurbishing what's there and expanding what's there. Limited footprint, so that creates some of the problems when we look at the arcs, the explosive arcs, due to the types of materials that are being used in the rockets. Some of those arcs overlap. And so our goal is to create a system that's a bit more dynamic, just saying that you can't work with inside this arc, but looking at risk mitigation and risk management to say, what can we do inside that arc to mitigate the risks and have it be a bit more dynamic as lots of different users are using the same spaces.
Right, and that's going to help with the increase in the launch tempo and stuff like that. Excellent. One more thing I wanted to ask you. You also mentioned I'm going to quote you, but it might not be quite a quote. But success lies in international cooperation. And so I wanted to ask you, we're here in an international location.
You bet.
So what does that look like in terms of international cooperation for what your office is doing, and what might some successful first steps look like?
Sure. Let me just start with a baseline of, hey, space is a shared domain without international borders. So if we start from that, the need to communicate, share situational awareness, and do all those things innate in how we operate. From a Space Force, from a Department of the Air Force perspective, what that means is, first, we'll have to start at the national level. There are a lot of stakeholders at the national level in the United States. I'm a part of a common standards working group with the NASA and FAA, and everybody has a stake in launch operations, on-orbit operations, and deorbit. And we need to come to a consensus for how we want to treat these things, what safe operations look like, and what our standards are. Once we can get there, we'll expand that out and set international standards as well. There are a lot of other spacefaring nations that have their own standards, and at some point we're going to try to, I think we'll endeavor to marry them up, because there are a lot of companies out there that are going to play in this space that will go to different locations, and we probably owe them something like that. So communications and information sharing is going to be critical.
Okay, so it's a matter of kind of getting your own house in order first.
100%.
And then going out.
A lot of work to be done still.
Yeah. Well, thank you very much for joining me.
Thank you. Appreciate your time.
To use the U.S. military standard of 882E, SAFE means identifying the hazard, being able to take steps to prevent them if possible, if not prevent them, to mitigate them, and if they still happen, to have steps to handle them and to track them all the way to the end of life.
So what does safety mean to me? Safety means the freedom from unreasonable risk. We cannot do the things we do without some risk. We just need to control it to whatever is reasonable.
Safe means for me that you can perform space operation without accident for a long time.
Hello, I'm here with Andrea Harrington from McGill University. Thank you for taking the time here at IAASS to join me for a little conversation.
Thanks for the invitation. I'm glad to be able to get an opportunity to talk about the legal aspects of space safety.
Yes, it's not just technical solutions. I've been hearing that all week, right? We really got to start leaning into the regulatory and legal parts of it. You start at the very top. So you gave a really interesting presentation. I wanted you to just kind of start off with our audience, just introduce them to Article 9 of the Outer Space Treaty.
Okay, so the Outer Space Treaty is the fundamental treaty that governs space activities. It sets out the fundamental principles by which states conduct their space activities. And so Article 9 is a large focus of my research because of the value that it has in helping with the development of new norms and tying those norms into the Outer Space Treaty. So there are three different obligations that are contained within Article 9. There's the due regard principle, there are the prohibitions on harmful contamination, and then there are the consultation provisions. What we're talking about here today, what I'm focused on, is specifically the due regard principle that says that states have to carry out their activities in space with due regard for the corresponding interests of other states. So it balances the interests of different states in their space activities in order to maximize the use of outer space that's guaranteed under Article 1 of the Outer Space Treaty.
Okay, so that kind of, in terms of norms of behavior, that might be something like don't park your vehicle too close to my vehicle.
Right, so when you're acting with due regard, you can say if you get within X distance of my object, whether it's on the lunar surface or whether it's in orbit, then you need to coordinate with me in order to act with due regard. So it's not to say you can't do that, but if you don't comply with that, we don't feel like you're acting with due regard for our activity. So in terms of a specific operation or a specific object, a state could make statements like that about their activities. And there's an example of that in a 2011 document, which is NASA's recommendations to spacefaring entities. And it was created at a time where the Google Lunar X Prize was looking at offering a bump up payment prize for approaching and taking pictures of lunar landing sites from the Apollo missions. And so NASA was concerned about the disruption to those sites or damage to the objects there, and came up with some of these distances where they thought it was safe to approach without causing damage to those objects or to those sites. So that's one example of how a state might make that unilateral kind of declaration, hey, to act with regard, here's what we think needs to happen. And so a state could say, okay, I intend to approach, let's see if we can coordinate to do that safely. But it's not a prohibition. So if the other state said, great, thanks for telling me, right? We had a conversation about it maybe, or maybe I just read your guidelines, but I'm aware that this is your position, I don't agree with it, I'm gonna do it anyway. You still could be acting with due regard, right? It depends on the circumstances and the situation. So really the object of due regard is to avoid unjustified disregard for another state's interests. And part of this balancing is taking into account the importance of each activity to the respective state. So any activity, right, may be something that's really significant to a state's essential interests, or it may be something that is a small commercial venture or, you know, a small effort on behalf of one educational institution to do a little experiment that maybe doesn't really influence fundamental science. And so you would, on balance, right, give more regard to the activity that really has a significant bearing on an interest of the state, as compared to something that had, you know, very little needed outcome for the state in question.
So I will point out that you are a lawyer, a law professor, and so the playing around with the meaning of the words, right? What is due regard? You've kind of mentioned how, well, it might not be, due regard is a little bit different than at least don't do it with complete disregard. Right, and then what you were just saying in terms of like the importance of the activity to the state, that is also a sliding scale, right? So that's really interesting that that can be argued probably indefinitely, those things.
Right, and so when you look at the language, you have to look at the modifiers. So you have two words, right? You have due and regard. So due modifies the amount of regard you have to give. So it's not total regard, it's not maximum regard, right? It's not the other state's activity is so important that you can't do anything that could infringe upon that activity. It's you give the amount of regard or the amount of consideration, if you think about it as consideration, that would be due. So you can also think about this concept of due regard, right, in your day-to-day life when you're having to interact with other people in traffic or on the sidewalk. How do you act with regard for other people? You don't change your entire, plan, your entire course to your destination based on one other person or entity's actions, but you generally act with due regard for everybody else around you to maximize efficiency. Everybody gets to where they're going, right? And we get there at the end of the day, even if somebody maybe had to take a step to the left or a step to the right on the sidewalk, everybody's still getting to their destination. And so it's an optimization activity, right? You're trying to optimize the maximum use of space activities that are not unduly infringing on other states' ability to have space activities. So this due regard concept is really the limitation on your Article 1 freedom of use to say that you can maximize your freedom of use up to the point where you would be acting with disregard, right? Not acting with due regard for other states' activities, and you get that same consideration from other states in return.
Right. And so the idea that we're signatories to the Outer Space Treaty, but because of the language used, it's not necessarily an obligation to listen to another party's what they consider to be disregard or an important.
So yeah, we have ratified the Outer Space Treaty, absolutely. We have an obligation to consider, right, in good faith, because good faith is a fundamental building block of treaty law.
And another subjective term.
Absolutely. but we don't have an obligation to avoid the consequences, right, that the other state may be trying to get not to happen, right? We don't have an obligation not to cause interference, for example. That doesn't fall within the due regard principle. Of course, in good faith, if there's an easy way to mitigate so that everybody gets their objectives met, right, and you can mitigate that interference, then you should be trying to do that, right? It's a conduct obligation, not a result obligation. So you conduct your activity in such a way that you're trying to take into account other states' needs, but sometimes it's not possible to do so and you just don't have a choice, in which case you can still be in compliance with the treaty, right? So it is a very tricky balancing test in that case, but it's also helpful to build language into any kind of agreements or guidelines, even if they're not binding, they're not treaties, that tie back to the due regard principle. So you would say, for example, if you were creating new space debris mitigation guidelines, in order to comply with our obligations to act with due regard under Article 9 of the Outer Space Treaty, we will take the following steps to mitigate the creation of space debris. Boom, 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 1, 2, 3. And then you create that very clear nexus back to the binding obligation in the treaty. It is a binding obligation to act with due regard, right? So it strengthens the power of your guidelines if you have that nexus, if you can tie back and hook onto something that exists in the binding law, even though your guidelines themselves are not binding law.
Okay, so you've kind of been talking about how this due regard can be applied to guidelines and stuff, but there's also something in the past where we can kind of show, you've shown in your research how this due regard idea is used in other domains.
Yeah, absolutely. So due regard shows up in a lot of contexts in international law, but the one that's most notable for my research is in the law of the sea. And if you look at the UN Convention on the Law of the Sea, there are uses and mentions of the due regard principle throughout the UN Convention on the Law of the Sea. It's really a fundamental way that we can govern and balance these kind of activities between states in a maritime context. And so therefore we also have case law that exists out there that we can look at and reference as to how due regard is being applied in real life. So as you pointed out, it's kind of a squishy concept, right? It's not very clear cut. For those of you who might be engineers watching, you're like, what the heck? This is not what I signed up for. But there are ways that courts and tribunals apply this. So the one that I like to use is from the Chagos arbitration. So it's an arbitral tribunal that wrote the decision, and it creates that balancing test, right? It says you have to balance the interest of and the significance of that interest of one state against the other state, and specifically that there is no universal formulation of due regard. So there's no universal way that you can take the same rule and apply it in every circumstance, because the activities are going to be different in every circumstance. Which states are involved, right? The equity of those states involved is going to be different. And so therefore, you have to do this on a case-by-case basis. And I also want to point out that the Outer Space Treaty is designed to protect certain rights in particular. So freedom of use of outer space specifically has to be available without discrimination, regardless of economic or technical development in a state, right? So there is this call out to specifically protect the interests of developing states. And there's the benefit principle that says space activities are meant to benefit all countries. And so you can use those also to help figure out your balancing test in any one particular circumstance between states.
Excellent, yeah. So there's a lot of food for thought here and a lot of ways that this can be applied, and no matter how squishy it is, there are things to tie back to, so.
Absolutely.
Yeah, thank you very much for joining me today and talking about this subject.
Thanks, happy to help.
Hello, I'm with Tommaso Sgobba, the Executive Director of IAASS, the International Association for the Advancement of Space Safety. Thank you very much for taking the time.
You're welcome.
So this has been a great conference. We're in a beautiful setting of Prague.
Absolutely.
I wanted to kind of pick at something that you presented on one of the first days that I sat in on the presentation, some research you've been doing about rescue. So first off, for people who might not know, can you just kind of describe what is special about Section 6 of the Artemis Accords?
Yes. Section 6 is in itself nothing new, truly, because there is the Outer Space Treaty that states exactly the same principle, which is basically the mutual aid in space and on Earth in case of an emergency. What Artemis Accord Section 6 does is to reinforce and commit the entire enterprise, let's say, to fulfill such article. So it's a promise, if you want, that needs to be fulfilled.
Right, and it's written like all good, very high-level policy. It's written a bit vaguely, so there are terms like reasonable efforts. I'm sure the lawyers could go around in circles about what reasonable was. There's a term like personnel, so that could include government astronauts. It could include space participants, and then even the term distress. Right, in this kind of emergency assistant clause,
could have many meanings.
Distress could have many meanings, exactly. So you, go ahead.
Yeah, no, the point is that if you think about rescue of a lunar mission, but because of an emergency on Earth, then okay, the reasonable effort means you are a country that has certain capabilities, and you are one of the signatory of the Artemis Accord, then you will do whatever possible, to come to aid. The problem comes when you want to apply, the article and the section of Artemis Accord to the lunar environment. Over there are no, let's say, rescue means for other purposes. On ground, there are rescue means for aviation disaster, maritime emergencies. On the moon, there is nothing.
There's no infrastructure at all.
There is no infrastructure.
Right.
So it's not that you can participate, you can aid according to your means. Either you have developed certain capability or you could do nothing. Okay.
And there's nothing in the accords that says you have to develop this capability. You don't want.
And there is nothing.
Right.
But if you don't truly interpret the section in the sense that you have to do something, then the meaning of the complete section becomes meaningless.
Right.
Therefore, the point is you need to develop certain capabilities, because only if you develop this capability, then you will be able to, make, contribution.
Rescue anybody,
rescue,
right. Yeah. So you kind of took some of this and you really zeroed in on specifically lunar rescue.
Yeah.
And you talked about some considerations that needed to be taken into account. The first thing you talked about was dust. Why do we have to care about dust?
Okay, very simple. Dust on the moon, let's say the following. We have a mechanism on the moon, which means that we will have rovers, rotating stuff, etc. So there are moving parts, mechanism. Now, of various sort and kind. When you are in vacuum, lubrication is in itself a problem, because everything tends to evaporate.
Okay.
On top of this, because you are in vacuum, there is no oxygen. The oxidation layers that are usually, naturally grown on top of surfaces, metallic surfaces, do not happen. This makes the movement of the mechanism challenging. There are, of course, techniques to help this. But if you are not only in vacuum, but you are also on the moon, there is this very fine and abrasive, highly abrasive dust, which is the moon dust, which can intrude in the mechanism, and it would be, the final straw that, kill the camel,
And it doesn't go anywhere, right? It takes a long time for the dust to settle. So even
but it is truly. If you see certain pictures of the Apollo astronaut on the moon, you will see that the dust is also attached to the suit.
Everything.
Everything.
It gets everywhere.
On the boots, everywhere.
Right.
So mechanism is the first consideration.
Okay.
Then there is a second consideration, which is linked to the fact that this dust would attach to the suit. It is rather difficult to dedust, in a natural way, if you want. And therefore, when the astronaut goes inside the habitat, if it does not perform properly a dedust, it would contaminate the internal air.
Right.
And it has been determined by research of various kinds that there could be damages to the lung, to the central nervous system, and even to the heart.
So the astronaut needs to dedust before they get inside all the way. Right.
And the dedusting, of course, is a function of the kind of fabric, tissue, and protection that you use on your suit, the kind of material over there, the technique that is used is calibrated on top of this, etc. So only if the suit is considered for dedusting, then the relevant process can be matched properly. So you need this for dedusting. Yeah.
So I know that you have another talk to go to. So I wanted to run through a couple other things as quickly as we can. You also said that navigation would be a consideration on any kind of emergency assistance on the lunar surface.
Yes. The moon surface is by definition the horizon is closer because the moon is smaller.
Right.
There are no landmarks. And you cannot.
And horizon being over the horizon, you can't see.
You can't
see.
So
you get right.
So small, no landmarks. On top of this, you cannot use your iPhone compass because there is no magnetic field. Okay, so you need a system to help you navigate, and it is very easy to get lost on the moon. And typically, what you need is a satellite-based navigation system.
Right, so the lunar PNT, if you will.
Yes, absolutely.
Yeah. You also talked about mobility.
Yeah.
So you're out there in the backwoods of the moon, you're collecting samples somewhere. Why is mobility important?
It's very, very important. In particular, if we look to this from the point of view of search and rescue, okay? I mean, the search somehow we have already addressed because of the navigation. The navigation, but you would need some additional feature like beacon, etc. But let's say that now somehow you have been identified, located. Now they have to come to rescue. Now the point about rescue, about mobility, is that on the moon surface you cannot move very fast. Okay. The maximum that has been reached and is projected to be, the ideal speed is 7 miles per hour.
Oh.
Okay. Now, imagine an ambulance that comes to help you into an emergency at 7 miles per hour. I mean, on top of this, you can expect distances between various bases. I mean, the US base, the China company, mining company base, etc.
Right.
Certain distances. And
hopefully. Hopefully we're not on top of each other. And
I would prefer to be as close as possible.
Interesting.
Exactly for this reason. Because if you are just, 5-6 miles away, this becomes a long journey to come to help you. And first, these are all electrical vehicles, and there is no station over there,
to plug in,
etc. So you must have the necessary autonomy. Okay, you must have the range to go and to come back. You must have the capability to load someone who could be also, need some position to be
certain medical requirement, even.
Medical requirement, etc. Now, if you don't consider all this from the very beginning, then you cannot truly expect to have someone coming to help you.
Right. And so then this kind of feeds into the last part I remember you talking about was that the kind of integrated systems So let's say you get somebody on your ambulance
Yeah.
and you very slowly go back to your home base. Who says you can even help this person?
The problem is you arrive over there and it is not just knocking on the door and they open the door and you go in. You go through an airlock, and when you go through an airlock, you have to connect to the life support system of the base. This means that your suit is designed to be interoperable with that system. So the umbilical, the adapter, the connection, they are all standardized. Otherwise, you may be in front of the hatch of an habitable module and basically having no possibility to go in. And it is not only certain, let's say, electrical data and physical dimension to be compatible. You need also have the processes, the famous dust. I mean, the de-dusting must be compatible with that other kind of suit, okay, and all the rest. So this means that you need to do on the moon something that you would for sure do on ground, on Earth, etc., where we are accustomed to help each other no matter what is the nationality.
Right.
NASA is developing lunar SAR, which is a system dedicated to, rescuing the
SAR,
moon.
search and rescue.
They are already developing it.
Right.
Now we need to make sure that this is fully compatible with what the Chinese are planning to do, and so on.
Yeah, I love the visual that you walking through these kind of technical challenges, the visual of what it could look like versus what we would like it to look like.
Yeah.
So thank you very much for
You are
joining
welcome.
today, and this has been a wonderful conference.
Thank you so much.
All right.
Thank you. Bye-bye.
Hello, I'm here at IAASS with Justin Hill of the Australian Space Agency. Thank you for coming.
Yeah, it's great to be here.
Yeah, so what do you do for IAASS?
So I'm the Director of Flight Safety in the Space Agency's Office of the Space Regulator, so essentially equivalent to the FAA's AST.
Okay, and so introduce our audience a little bit to Australian Watch. Things have been changing recently, right?
Yeah, so I suppose the short of it is that the Australian space ecosystem is really growing, and that's kind of based on our geography and low population. So we're really well placed for launch and re-entry activities in Australia.
You have a lot fewer people than Florida, and you got a lot of coastline.
Exactly right, and fairly low air and maritime traffic, which is really beneficial.
Right.
So what we're seeing is an increase in the number of launch and re-entry applications, and we've also seen the establishment of several commercial spaceports in Australia, which is somewhat different to the US model in terms of there being government spaceports in the majority, but we have commercial spaceports.
And so do you have only commercial spaceports?
Yeah, essentially. So we have some government ranges in Australia, but for us within the Space Agency, we only regulate commercial spaceports. We've had several commercial spaceports established from the north of the country down to the south over the last kind of 5 years.
So how many are we talking here?
We're talking, in terms of licensed facilities, at least 4 facilities, and then we've got a number of facilities that are either being established or where there's interest in establishing those facilities in Australia.
And that's all coming from that commercial sector.
Yeah, exactly, which is really great to see. And I suppose one of the other things that is, potentially driving that growth is the fact that we recently signed the Technology Safeguards Agreement with the US, which allows for US launch companies to come to Australia and launch their rockets in Australia.
Okay.
Yeah.
Is that similar to being kind of, I know in New Zealand there's a commercial launch facility that has an FAA license for launching. Is that similar to this, or is it slightly?
Similar. The New Zealanders have a TSA in place with the USA, but they've also aligned their regulatory approach, as far as I understand, because I'm not an expert on New Zealand regulation. But I think they've aligned their approach with Part 450. And the good thing about Australian regulation that I can say is that we're fairly well aligned with 450 as well in terms of like our core safety principles. And I think that's one of the things that I really tried to reinforce during our presentation yesterday, is that in terms of our core safety standards, we're well aligned with the US. and we're trying to build on that further into the future.
Right. So yesterday you and Sean Wilson presented some of your research on this. So
Yes.
kind of let's talk about that a little bit in terms of the risk-based assessment and how you guys are looking at that.
Yeah, so we kind of spoke about our regulatory framework and how we're trying to adapt that to the growing space ecosystem in Australia. And one of the things that we really want to do is get better at understanding the risk associated with the launch or re-entry activity in Australia and understanding that risk quickly so that we can tailor the safety case appropriately. So if the risk is low for the activity, then hopefully we can have a safety case which doesn't involve as much work for the applicant. Right,
That's always good.
Commercial
will like this.
That's what we'd like to do, so that we can reduce the application processing time. So that's the
Right.
point that we'd like to get to, and that's what we're really focused on doing as a regulator, to really meet that increased demand.
Right.
Yeah.
And so this is similar to in the United States, we're doing this kind of responsive launch idea of being
Yes.
able to move fast, be agile.
Yeah,
And this
exactly
is
right.
something that a kind of behemoth organization like the United States space industry or the space sector, it's like moving a large ship, right? It just kind of goes slow. So you guys
Yeah.
are introducing that agility.
Well, that's what we want to do, yeah. Because I think, it's a really good problem for us to have increased demand, and we really want to adapt as a regulator to be able to meet that increased demand. And one of the things that we're really aiming to do is build our capacity and our capability as a regulator, particularly in flight safety, and release more guidelines and guidance material to our applicants so they kind of understand what good looks like for an application.
What would be an example of, you said, to something that is a little bit less risky and being able to, what would be an example in terms of an activity that might be able to be streamlined a little bit better?
Yeah, that's a really good question. So say, for example, you had a US launch vehicle that had a whole bunch of flight heritage coming to Australia to conduct a launch, and they were conducting that launch, say, over ocean with limited population, then that would be a really good example where we could look at that and go, well, actually, it's had previous FAA approval and it has to have an FAA approval to launch in Australia anyway. So we could look at opportunities to align with the FAA, and also, based on the risk associated with the launch, potentially, reduce the effort required for the safety case provided to us.
Right. Almost like a
Yeah.
plug and play. Like, we've been there, we've done that. Let's just do it again all the
Yeah.
same way. Check the same boxes.
Try to leverage as much of, the approval process in the US as much as we possibly can,
Right.
to be able to, reduce the application overheads in Australia.
Right.
Yeah.
Excellent. Okay, well, I think that covers it. Is there anything else that you wanted to share with our audience in terms of what the Australian Space Agency has been doing lately?
Actually, one thing I did want to mention is that we still maintain good relationships with Australian Defence, and we really try to maintain alignment with the defence regulator in Australia as well. And that's one thing that we're really focused on, is being in a situation where our regulatory processes for space in Australia align regardless of whether it's civil or defence as well.
And who is the military regulator?
The Defence Aviation Safety Authority.
Okay.
Yeah.
Okay, the aviation word.
Yes.
I've been hearing that a lot lately in terms of how we can transfer some aviation regulations into space for commercial companies.
Yeah, exactly. And there's a lot that we can learn from them as well.
Yeah, absolutely. Well, thank you very much, Justin, for joining me today.
Not a problem. Thanks for having me.
Bye.
Bye.
Safety for me is related to the technical aspects of our values. While security, it's a bit different for me as a lawyer, of course, that it related both to safety and in the technical meaning, and a bit to some political issues. Like
these terms, safe and secure, they are the same for safety and security. They are intertwined, but basically safety is about people doing their best. It doesn't end up very well all the time because of humans and equipment and all that. Security and secure is the security side of things, which is basically someone trying to harm the system.
Secure. What comes into my mind is cybersecurity, encryption, data protection level, these kind of things.
Well, as you can see, IAASS really brings together a wide variety of experts for their annual conference. This is the 13th one so far. And they talk about anything from the really hard technical challenges for launch and re-entry, debris and safety and operations, as well as even design, right? Those technical challenges. Of course, the Space Policy Show is more interested in the governance and regulatory challenges, but those need to be talked about in tandem, both the technical challenges and governance, and the solutions lie within both of them. So you can find more of our research from the Center for Space Policy and Strategy at csps.aerospace.org. Thank you to James Liggins, our technical director, and thank you for joining.